introduction of the adsorption. Okay, I hope that everyone get ready. So the quiz is going to be in Kalam. So make sure that everyone already know how to log in to Kalam. Sebab ada yang tak tahu juga. So please, okay, Kalam nak kena tahu. Okay, nampak tak slide?
Nampak, Doktor.
Nampak, Doktor.
Alright. Okay, since today the class is recorded, then I think you can find later on the recorded version in the Microsoft Teams. I will not post the link for today's class in the any of the platform, Telegram or Kalam and so on. But I think itself you can go to the Microsoft Teams. They gonna give you notification that recording is available for this one, so that you can just download it and then can view the recorded version. Okay, so our first chapter is going to be the adsorption. All right, so what is the adsorption basically? So this one you need to know. So this is basically to address your course outcome 1. Okay, explain and then you know how the principle of the adsorption. This is now is adsorption. So adsorption is basically you have like, okay, if you remember that in the unit operation, for those that already took unit operation, you have what we call it absorption, AB. The spelling, the difference is only this, B and D. That is the difference, as absorption and adsorption. So here in separation, we learn about adsorption process. Okay, so adsorption must involve, okay, the phase that involve is basically, we call it fluid. Okay, the fluid could be gas or liquid. So you have like fluid, gas or liquid are absorbed on the surface of solid adsorbent. We call it adsorbent. So they have solid. So you know that the interaction between gas or liquid dengan solid. So this is what we call it adsorption. Okay, you have like component that you have in the gas or liquid phase that are being absorbed on the solid surface of adsorbent. So this solid, we call it adsorbent. Okay, in adsorption, we call it adsorbent. Right, so this is the definition for adsorption. So this must be present, solid must be present as adsorbent. So not necessarily the solid must be adsorbent. Kalau kata dia solid dia, like for example you have like apa solid you, like rock, you are the rock, you are the sand, it's also solid. But if it's not called adsorbent, they cannot absorb. The adsorption cannot occur. So this adsorbent, basically they have a special characteristic. What is the characteristic? Okay, characteristic dia ada what we call it porosity. Okay, dia ada porosity. They must have this porosity. So what is the function of this porous structure in the adsorbent? Okay, the function of this porous ni dia ada liang-liang lah. Kalau for those that not familiar with porous, it's a liang-liang. Simply example dia, let's say you observe, kalau you ada sponge sponge tu you nampak dia macam ada liang-liang halus. So that is porous lah. Alright. So that porous, what is the function? Okay, this is what how the mechanism happen. So this is dia punya fluid. Okay, let's say this is fluid, either gas or liquid. So in that gas and liquid you have component yang you nak absorb. Let's say component A lah. Okay, component A. So this is yang black ni. Black dot is basically component A. So what happened? This component A, they akan diffuse, and then they go to the surface of the solid adsorbent. Okay, dia dah banyak kat solid surface ni. So that component A will going through inside this pore. Okay, this pore, the porosity, the pore, and then they're gonna stuck there. Okay, they're gonna go inside, gonna start there, and then they're gonna lock there inside that pore. Okay, so when they lock, so they cannot go out. So they cannot go out. So means that it's already absorbed. All right. So but this absorption is basically can be reversible. Reversible means that once they trap here, you can push it to go out. So how you want to push it? So basically you can go through to what we call it regeneration process. Okay, they have a few generation method you can apply. So whereby when it start here in the pore, inside the pore, you can push it to go out. So how to push it to go out? You can use a temperature swing whereby you play around with temperature. So then the solute A ni akan move away from the pore. And then you can also apply pressure. You play around with pressure. That why they call it swing, because the pressure is going out and going up, going down, something like that. And then or you can use inert or purge stripping. Stripping ni macam mana? So you're gonna passing inert gas or purge gas on that surface, so that you're gonna push that component A to go out. Something like that. That is the inert purge stripping. Okay, another one, the last one, we call it displacement purge cycle. Dia macam inert, but now they don't use inert gas, but rather than they use purge gas. Okay, purge gas. Why they call it purge gas? Because inside this gas you have like components that are more absorbed towards this adsorbent. So let's say you have component A here. So here in the gas you get component B. So this component B, the absorptivity is higher than A. So what happen? B ni akan replace A. So A akan go out. So B akan retain dekat dalam pore. But finally you need to remove the A juga out. So that's why the replacement per cycle is not favorable, because you have to apply another step to remove the B pula. Boleh faham? Question? Hello? Tak ada orang. So that's why I require you starting next week to switch on your camera, so I know that you there or not. Okay, so then in this process, we call it physical adsorption. It's only physical adsorption because of what? The solute is trapped in that pore, and later on you can release, you can push it away from the pore again. Okay, you can push it away and then you can use. Okay, once you push it, then this adsorbent you can use again. Alright, so it's basically physical adsorption or van der Waal principle. Okay, so overall adsorption process consists of several steps. So this is the step that I already explained. Solute diffuse to the surface, and then they go inside, and then they absorb. Alright. So when they saturated, okay, saturated means that all the pore here, saturated adsorbent means that all the pore here already filled with the solute. What we call it solute or component yang you nak absorb tu. So then that is reaching saturated. Reaching saturated meaning that they cannot absorb anymore because there's no space, the pore that can absorb. Right? So what happens? You can apply this regeneration method. So next week gonna be quiz. Maybe I'm gonna asking about this lah. Okay, how the generation happen. So how to do this temperature swing and so on. So be ready. So to know that whether you already get the CO1 or not for specifically for adsorption punya topik. Simple je. So kalau kat situ tak dapat jawab, maknanya daripada 100% akan kurang lah, jadi 98% contohnya. Because the quiz going to be contribute about one quiz, each quiz will about 1 or 2% lah, 1% lah lebih kurang. Kalau kita ada 5 quiz, we have 5%, each quiz going to contribute to 1%. You see that the marks may be not significantly impacted, but that 1% could be made different between C minus and C. Because maybe your mark is 59, so you need another 1 mark to get 60. 60 already change your grade, betul tak? So I don't want that your PA gonna appeal to the lecturer, please, my student get net 59, please increase. No, it's basically based on your performance, you deserve it. If it's a B, and it's a B. If it's 59, because you deserve to 59, not 60. Okay, so in the close look, okay, in the adsorbent, you can see that like this. This is the structure of porous structure of the adsorbent. So must have this one. If you don't have this one, the solid cannot be called adsorbent, and then they cannot function as dalam adsorption process. They cannot do the adsorption process. So adsorbent can be pellet, bits, or granule. Size dia is one. So porous structure could be up to 50% volume. Okay, porous structure meaning that the one that have this pore, if you sum it, like 50% volume can reach to that level. All right. So this one is like example of the type of adsorbent. Okay, that commonly can be found. So I don't want to go detail on it. This is like a reading material. You can read through to understand. If you not really convincing about the information that you have here, you can Google. So now this is very easy to get more information. All right. So this one I just go very fast. So you have like activated carbon. So this is like example of activated carbon, because sometimes the size is very fine, sometimes the size is core size. So it depends. Normally it's from thermal decomposition of biomaterial like wood, vegetable shell, coal, and so on. All right, so they have like the properties. Normally we're going to look into the surface area, average pore diameter. So what is this one? The surface area is surface area. Each of them, they have this surface area. If you have like higher surface area, you can have like more adsorption occur there. All right, and pore diameter is basically the size of the pore. Okay, the size of this pore. Okay, this is your pore. What is the size? So it's 10 to 60 angstrom, meaning that if the molecule of the compound or solute, we call it solute that you want to absorb, is between this size, so of course they're gonna go to that pores. If the size is bigger, you cannot push that to absorb in that pore. Okay, that is very simple. How to know this one is suitable or not suitable? Okay, depending on the size of the solute. So this is a silica gel. Okay, I just go very fast. Okay, I don't want to go detail here because you already know what is surface area, what is the pore size. Okay, they're gonna change. Okay, according to the material type. Activated alumina. This is the photo, the real photo example. And this is a molecular safe zeolite. So this is, they have like one is in the form of cylinder, one is a sphere. So it depends, right? It's made of alumina silicate. Synthetic polymer or resin. So this is from polymerizing two monomers. If it's made of styrene and divinil resin, used for adsorb non-polar organic. I hope you can go back to refer to your organic chemistry. What is non-polar, what is polar? So that you know that, oh, type of polar or non-polar, what is that? So maybe the quiz question going to be like, give example of non-polar compound that can be adsorbed by using styrene, dibenzene, synthetic polymer. Okay, this is soalan bocor. Mungkin tak keluar, mungkin keluar. Alright, and then for polar, normally they made up from acrylic ester. Alright, so this is like example dia punya synthetic polymer or resin. So normally resin macam ni lah, dia sangat-sangat like a salt, right? So this is anion resin. You see that the bits is very small. Okay, this is anion, this is cation. Anion to absorb the anion, cation to absorb the cation. So you know that the metal ion, you have cation and anion. So this is, we use it in the ion exchange. So this classification of this one, synthetic polymer or resin. So this is resin one. Okay, about the application. Okay, you see that in the application you have sometimes if you look here, the type of adsorbent like as silica gel, activated alumina, activated carbon, they have like more or less the same application. Like for example here, drying gases. Here also you have drying gases. Here you have like not drying gases but removal like hydrogen. Some of them they have like a similar application. But finally, when you want to decide which one is best for your application, it depends on your process. Okay, maybe you can choose silica between silica and activated carbon, but later on gonna go to the economic analysis. For example, maybe silica gel is like more expensive, or reaching longer saturated period compared to activated carbon. Then from there you can choose silica gel or activated carbon. You need to do some analysis. Even the application, it could be in the same function. Okay, same goes to zeolite and polymer. So you can see that this is typical, not solely on this, but they also can have so many others. Okay, this is the regeneration method that I told you. Once it's reached saturated, and then you can regen it so that the solute that trapped can escape from the pores, and then you can use again your adsorbent. So like for example, temperature swing, normally you're gonna apply heating. You're gonna heat up. Okay, when you heat up, the solute A will go away from the pores. Pressure swing, what happened? You need to reduce the pressure. So when you reduce the pressure, so what happened? The solute A akan push out. Right, this is pressure. You need to reduce the pressure. So then they akan push out. In the temperature, so this is your pore. So this is your solute. Temperature you need to increase. When you increase, they're gonna go out. Right? Inert purge, of course lah. You just passing that I already explained. Okay, in the first slide, you passing with the inert, and then you're gonna push the solute go out. Displacement in your gas that you supply, you need to have like other solute that are more absorptivity than the solute that already absorbed. So they're gonna replace it, like replace B here, and A is going out. Finally, you need to remove also the A. All right. So this is the impact if you apply temperature or pressure swing in terms of graphical lah. So why in the temperature you need to increase the temperature so that the solute A will go away, and in pressure why you need to reduce the pressure, and then the solute will go away. All right. So please read through this one. Okay, understand it. So we're gonna anything you will ask me next week. Okay, I hope that you studied it first, and then if you don't understand, ask me next week about why temperature swing you need to increase the temperature, pressure you need to decrease. Basically, they are mostly related to this one, adsorbent loading, what we call it Q. Adsorbent loading, the unit is basically milligram or gram or mass of adsorbate. Adsorbate means the solute. Okay, sometimes they call it adsorbate or solute over mass of adsorbent. So let's say you have 1 kilo of adsorbent, activated carbon, for example. So how much adsorbate or solute can absorb in 1 kilo? As you have more mass, more solute or adsorbate you can absorb. That is normal, right? So in a mass, in a kilo, for example, how much they're going to be absorbed? They represented as a Q or adsorbent loading. So that we're going to determine with that amount of adsorbent that you have, how much you can absorb. All right. So try to understand this one, and anything we can discuss it next week, because now it's already 11:51. So, and then also please read through this one, isotherm. Next week I will just go in brief. So because I expect that you already understand it, and if you don't understand it, ask question during next week class. Okay, because here this adsorption isotherm we just learned about 3 types: linear, Freundlich, and Lamoué. But basically we have more than 3. We have a long list of isotherm, but in this class we only learn about these 3. And please understand about their equation and then how you want to use that. Okay, so I think that's all for today. But before I stop the class, so I need to hear any question from you, all of you. Ada soalan?
So far no, Doctor.
So far, no. Okay. All right. Remember, starting next week, you're gonna switch on your camera. Okay. So I know your reaction. If you are compulsory to come back to UMP, so you're gonna have like face-to-face class. So no need to open up camera that time. Okay. So.